Let's look at a couple more examples from the book. In problem number 24, we're asked to find the definite integral from -8 to -1 of x minus x squared over twice the cube root of x. To begin with, let's see if we can break down the integrand so that we can use the power rule to find the antiderivative. To begin with, notice that I have a factor of 1/2, which is a constant, and we can factor constants out of the definite integral. I can also rewrite this denominator as x to the 1/3 power. So now this looks a little bit better. I can also bring this x to the 1/3 up to the numerator if I give it a negative exponent. Now when I distribute this x to the negative 1/3 into this binomial, I'll need to add exponents. And remember, the understood exponent on the x is a 1. So let's do that. I'll bring along the 1/2 in front. And now let's multiply in. X to the negative third times x to the first is going to be x to the negative third plus 1. I need to add those exponents. Minus, when I multiply x to the negative third times x squared, I get x to the negative 1/3 plus 2, adding those exponents. So here I need to take negative 1/3 plus 1. Here I need to take a negative 1/3 plus 2. Let's do that arithmetic. Negative 1/3 plus 1 is negative 1/3 plus 3/3, and 3 minus 1 is 2. So this first exponent is x to the 2/3. For the second one, negative 1/3 plus 2 is the same as negative 1/3 plus 6/3, and 6 minus 1 is 5. So this exponent is x to the 5/3. So now, the integrand's in a great form for applying the power rule. So, just to remind you, the antiderivative of x to the n I get by adding 1 to the exponent and then multiplying by the reciprocal of the new exponent. So I add 1 to the exponent and then I put the reciprocal in front. So first of all, I need to take 2/3 and add 1. Two-thirds plus 1 is the same as 2/3 plus 3/3, which is 5/3. So 2/3 plus 1 is 5/3, and then I multiply by the reciprocal, 3/5, minus, and now I'll go through the same procedure over here. I need to add 1 to the exponent, so I'm taking 5/3 plus 3/3, which is 8/3. And then I multiply by the reciprocal, 3/8. And now I need to take that from -8 to -1. Let's go ahead and distribute the 1/2, and then there's going to be a fair amount of arithmetic we need to do when we plug the -8 and the -1 in. So I have 3/10 x to the 5/3 minus 3/16 x to the 8/3, taken from -8 to -1. So first I plug in the top bound. That will give me 3/10 times -1 to the 5/3 minus 3/16 times negative 1 to the 8 thirds minus 3/10 times negative 8 to the 5 thirds minus 3/16 times negative 8 to the 8 thirds. So plug in the top one and the bottom one and subtract. Let's see if we can make it through this arithmetic. First of all, let me remind you what these fractional exponents mean. Negative 1 to the 5 thirds means the cube root of negative 1 raised to the 5th power. Negative 1 to the 8 thirds is the cube root of negative 1 raised to the 8th power. Let's write down the same expressions over here. I'll have 3/10 times the cube root of negative 8 raised to the 5th minus 3/16 times the cube root of negative 8 raised to the 8th power. The cube root of negative 1 is negative 1. Again, over here, the cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. And again, the cube root of negative 8 is negative 2. So I have 3/10 times negative 1 to the 5th minus 3/16 times negative 1 to the 8th minus 3/10 times negative 2 to the 5th minus 3/16 times negative 2 to the 8th. Now taking these powers, negative 1 to the 5th is negative 1. Negative 1 to the 8th is positive 1. Negative 2 to the 5th is negative 32. And negative 2 to the 8th is 256. So let's see if we can remove parentheses. I have a negative 3/10 minus 3/16. I have a minus times a minus 32 times 3/10. So that's going to be a plus 96 over 10. Then I have a minus times a minus is also a plus. 3 times 256 is 768 over 16. Now, before I do anything with common denominators, let me go ahead and combine the terms that already have common denominators. I can combine the negative 3/10 with the positive 96/10 to get 93 over 10. And I can combine the negative 3 over 16 with the positive 768 over 16 to get 765 over 16. And now I just have two fractions that I need to combine. The common denominator here, the least common denominator between 10 and 16 is going to be 80. So we need to multiply the first fraction by 8 over 8 and the second one by 5 over 5. So common denominator is 80. 8 times 93 is 744. And 5 times 765 is 3825. So finally, adding those two things together, I get 4,569 over 80. Wow, that one was bare. But notice that almost all of it was arithmetic. Everything on screen here is just arithmetic. Let's do one more example from the book, and that'll be the last one for section 4.4. And this is problem number 42, which asks us to find the area of the region bounded by y equals x cubed plus x equals 2, and y equals 0. Let's draw a quick sketch. Y equals x cubed plus x is a cubic function that looks something like this. X equals 2 is a vertical line crossing the x-axis at 2. And y equals 0 is another name for the x-axis. So the region, which is completely bounded by these, is going to be this one that's roughly shaped like a triangle. So notice that this region lies between 0 and 2 on the x-axis, and the top edge of it is given by the function y equals x cubed plus x. So we know that the area is given by the definite integral of that function between 0 and 2. Now, in an earlier section, we would have done this using Riemann's sums, but now we can find the area just using antiderivatives. First of all, we take the antiderivative of x cubed plus x, which is 1/4 x to the 4th, plus a half x squared, and then applying the fundamental theorem of calculus, part 1, I plug in the 2 endpoints and subtract. So I have 1/4 of 2 to the 4th plus a half of 2 squared minus 1/4 of 0 to the 4th plus a half of 0 squared. Simplifying, 2 to the 4th is 16, and 16 over 4 is 4. A half of 2 squared is half of 4, which is 2. 1/4 of 0 to the 4th is 0, and half of 0 squared is 0. And then 4 plus 2 is 6. So the area of this region is 6.